And once again, welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video, I want us to explain example 3 of shape and space 8, still under vectors. S is 1, 2, T is 3, 0, and U is minus 2, 5. All these are column vectors. Express in column vectors, vector P, which is S plus T plus U. And vector P, as you would know, it is actually S, which is 1, 2, plus T, which is 3, 0, plus U, which is minus 2, 5. All the terms on top there, on the top row, are always talking about the x displacement, x-axis displacement. So we would want to add all of them to see the entire x-axis displacement. And this is it, 1 plus 3, which is 4, plus minus 2, 4 minus 2 is 2, and then 2 plus 0, 2 plus 5, 7. So the resultant vector P is 2, 7, meaning 2 steps along the x-axis and entirely 7 steps along the y-axis. Part B will be sketched on the graph paper the way it's appearing here. And as you can see, I would want us to have vector P, which is 1, 2, plus 3, 0, plus minus 2, 5. And we may start somewhere. We may start here and see what happens now. Let us have this point as the starting point. Let us have this point as starting point. Point P, 1, 2, that means 1, 1, 2. This is vector S. And then from there, 3, 0, 1, 2, 3, 0. This is vector, I think, T. And U is minus 2, 5. U is minus 2, 5. Meaning now from here we go to the left, 1, 2, then 1, 2, 3, 4, 5. This is the vector U. This is vector U. But now, as this is ST and this is U. The starting point is this and the end point is this. So we just have a resultant vector which is running from the starting point. This is now what you're calling vector P. And vector P is from here to here is 1, 2, 1, 2, 3, 4, 5, 6, 7. This is 2, 7, which is vector P. That is exactly how we have observed. That is part B. And then let us respond part C of the same. The magnitude of P, as you know, right from example 1 and also example 2, the size of vector P is the root of the x displacement squared, the y plus the y displacement squared, basically by the use of the Pythagoras theorem, which is 4 plus 49 is the root of 53, which is what? Which is 7.28. Now that is 1. We have discussed about vector P. Let us go to vector Q. Vector Q is S minus 2T minus U. S is 1, 2 plus minus 2 what? Minus 2T, which is 3, 0, plus minus U. And you know minus U is the negative of both of these. So minus 2 is 2, and this is minus 5. That is vector Q for you. Now the entire vector becomes this one, as you look at it, it's going to be vector Q is now going to be 1, 2 plus minus 6, 0. We multiply this bracket out, plus 2 minus 5. And let us add all of them together. So 1 minus 6 That is minus 5 plus 2 minus 3, and 2 plus 0 is 2. 2 plus minus 5 is another minus 3. And that is just like it. And as you look at it, we are going to have vector q now. We are going to have vector q here. Let us have vector q, which is actually s minus 2t minus u. And basically, what are we saying? 1, 2 plus minus 6, 0 plus 2 minus 5. And let us now sketch it on this particular graph paper. And let us have our starting point. This is our starting point. First of all, 1, 2. So 1, 1, 2, this vector. And we call it vector S. And then minus 6, 0. From here to the left, 6 steps. 1, 2, 3, 4, 5, 6. The whole of this vector towards this direction is minus 2t. And then 2 minus 5 from here, 1, 2. 1, 2, 3, 4, 5. This is our final vector, which is minus u. But the starting point is here, and the terminal point is there. We just connect the 2 points, and this is our resultant vector. Our starting point is here, and our terminal point is here. We just connect the 2 points, and we have a resultant vector, which is vector q, which is equals to 1, 2, 3, minus 3, then down 1, 2, 3, another minus 3, and that is just like it. The magnitude, so to speak, we know now the magnitude of q is basically the square root of minus 3 squared plus minus 3 squared, which is the root of 9 plus 9, the root of 18, which is easily 4.2. 4.2, and there we are. Let us now go to the final vector. The final vector, which is talking of vector r, and vector r is 3s, 3, 1, 2, plus t, 3, 0, plus minus 2u, minus 2, 5. Basically, we are having vector r as 3, 6, multiplied by 3, plus 3, 0, and then plus negative, negative 4, minus 10. And what we are having here, finally, is 3 plus 3, 6 plus 4, 10. And this is 6 plus 0, 6 minus 10, minus 4. Probably we may finish with the magnitude first. The magnitude of r, let's see, the magnitude of r is the root of 10 squared plus minus 4 squared, which is the root of 116, because this is 100 plus 16, which is 10.8 to 1 decimal place, or to 3 significant figures. But now we need to sketch it. Sketch the vector s, which is vector s, which is supposed to be 3s, not vector s, but vector r. Let us sketch vector r, which is equals to 3s plus t minus 2u. And we are realizing that vector r is 3, 6, plus 3, 0, plus 4 minus 10. And even if we were to start sketching the graph, we can even start, let's start here, 3, 0, 3, 6 rather. Let us talk about 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. this is the vector that is talking about 3s. From there, 3, 0. From here, 1, 2, 3. This is vector t. And then from there, 4 minus 10. 1, 2, 3, 4. And then minus meaning along the y-axis but downwards, 10 steps. So 1, 2, 3, 4, 5, 6, 7, 8. Let us see that. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This now becomes the third vector, which is minus 2u. But as you can see, this is the original starting point, and this is the final terminal point. So we just connect the two with a straight line, and we call this vector r, which is from here. From here, we are going to talk about 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then downwards, 1, 2, 3, 4, which is 10 minus 4, which is exactly what we realized in part A of that question. That is it. And we have finished that part. We can see we were to talk about the column vectors, we were to talk about the magnitude, and we were also to sketch the 3 vectors, which is quite an involving question, but we have finished. Thank you. Let us meet in the next video. Of course, remember to subscribe, remember to share, and remember to comment. Let us meet in the next video.